So still today we want to talk about resultant vectors. But this time around we are talking about resultant of still two vectors acting at a point at an angle that is different from 90 degrees. Two vectors acting at a point at an angle that is not 90 degrees. So if you have that kind of case where you have two vectors acting at a point at an angle that is not 90 degrees, which can be represented this way. You have one vector here, you have vector 2. They are acting at this point at an angle, they are inclined at an angle phi. To find the magnitude, we just employ this formula right here. This will give us the magnitude of their resultant vector. So anytime you have two vectors acting at a point at an angle that is different from 90 degrees, employ this formula to get its magnitude. Now this also captures what we are talking about, but it's showing the resultant vector, and you are seeing theta. This theta gives the direction of the resultant vector. So to get the direction of the resultant vector, you employ this formula. Good. So once again, phi is the angle in between V1 and V2. The angle at which V1 and V2 are acting at a point. While theta is used to represent the direction of the resultant vector, which to get your theta, you employ this formula. In following classes, we will show how we derive sine rho and how the formula follows from sine rho. Similarly, we will derive this formula, but in any case such as this, to get magnitude you use this formula, and to get direction you employ this formula. And here on the board we have an example of such two forces of magnitude 2n and 3n. They are acting at a point O, and they are inclined at an angle of 60 degrees. So this is what we are just talking about. It's a classical example of what we are discussing on. Two forces 2n and 3n. They are acting at a point and they are inclined to each other at 60 degrees to each other. Now if you choose, you can still represent it, or you can just quickly run to the formula and get your answer. But if you represent it, it will be something of this nature. This vector is for the first vector 2n, and the other vector is 3n. The vector we are dealing on here are forces, and the angle between them is 60 degrees. Now mind you, this formula you have to respect it. You don't take this v1 as any vector. This v1 has to be the first vector so that you don't get it wrong. Because if you use it alternatively, because of how this formula is derived, you will get a wrong answer. So your v1 has to be this first vector and v2 has to be the second vector. Things is not allowed to be changed. Now in this case we have represented this question. You can just solve right away to get the magnitude, which is rho square v1 square plus v2 square minus 2v1 v2 cos 180 minus 5. In this particular example, v1 is 2, so 2 square plus 3 square minus 2v1 v2. They are all added together by multiplication, so it becomes 2 times V1 still remains 2 times V2, which is 3 times cos 180. The angle in between V1 and V2 is 60, so 180 minus 60. So this will give us r square is equals to 2 raised to power 2 is 4 plus 9. 3 square will give us 9 minus 2 times 2 times 3. You have to handle the multiplication first. 2 times 2 times 3, which will give us 12 times cos 180 minus 60 will give us 120 cos 120. Now this leads us to 4 plus 9 is 13 minus 12 times cos 120 is minus 0.5 minus 0.5. Now from here to this place, r square. Now to times this negative sign, we have fed this negative sign. Mind you, you have to be mindful of this sign. This is minus 0.5, and at the back of 12 is also negative sign. So the minus times minus will now give us plus. So 13 plus 12 times 0.5, which should give us 6. Which should give us what? 6. R square is equals to 13 plus 3, which is 19. We are not looking for r square, we are looking for what? R. So to get our r, we square root both sides. We square root both sides. So square root of 19. So we now get r is equals to square root 19, because what the vector we are adding here is our forces. So the unit will be in Newton. The unit will be in Newton. Now, so this is for the magnitude of the resultant vector. The magnitude of the resultant vector. So we still want to go ahead to get the what? Direction of the resultant vector, which we denote as theta. We just quickly employ this formula. Theta is equals to arctan or inverse tan. Arctan or inverse tan. V1 sine alpha over V2 plus V1 cos phi. V1 cos phi. Now, from this place, it will lead us to theta is equals to r tan. Our V1 is 2 times sine, and the angle in which the two vectors are inclined is 60. So phi is 60. Sine 60 over V2 is 3 plus V1 cos theta. So V1 is still remains 2 times cos 60. Now theta is equals to r tan. Now when you deal with the numerator, 2 times sine 60 will give us 0.866. And the denominator 3 plus 2 times cos 60 will give us 0.5. So we move on. Theta is equal to arctan 2 times 0.86 will give us 2 times 0.86 will give us 1.732. That is for the numerator. Then we times before we multiply. 2 times 0.5, which is half of 2, which is 1. So 1 plus 3 will give us 4. 2 times 0.5, 1. 1 plus this 3, which will give us 4. So you go ahead to divide this, and before we take the tan, theta is equal to arctan. When you divide 1.732 by 4, we get 1.732 by 4, you will get 0.433. Yes, that is that. Now you now take the arc, the inverse tan of this. So when you take the inverse tan of that, you will get 23.4. So this is the direction of the resultant vector. Therefore, the unit is degree. So that is that. So it's simple. Anytime you have two vectors acting at a point inclined at an angle that is different from 90 degrees, you just quickly make use of this formula to get the magnitude of the resultant vector, and you make use of this formula to get the direction of the resultant vector. Now there are still many cases where you add vectors to get resultant vector. There are still other cases. Now other time we're talking about ever since we have been dealing with two vectors acting at a point. Can you have more than two vectors acting at a point? If you have more than two vectors acting at a point, how do you go ahead in summing them up to get their resultant vector? That is what we wish to do next time.